Hey, good morning, everyone. Welcome to the Crypto Lounge. Welcome to the block of ICOR BP, or International Council of Registered Blockchain Professionals. And today we're going to talk about a very beautiful topic. And we have a special guest, our, should I say, subject matter expert. And we've been we've been out for quite some time, but we're coming back, and it'll be a bang for 2024. So let me bring in our guest for today, our subject matter expert. He's no other than Professor Mohit Vashistha.
Hello everyone. I am Mohit Vashistha. So thank you so much, Dr. Vince, for having me in the session. And I'll be speaking about the topic zero knowledge proof today. And I have around 5+ years of experience in blockchain space and in cryptography space. So I have been contributing, developing applications, protocols, researching on cryptographic primitives related to blockchain and zero knowledge proofs. So I'm quite excited to join you on this session.
Thank you so much for being here. And here also here with us as my co-host, the founder and CEO of Altas University, ICOR BP, HTML Coin, needs no further introduction, Amando, Boncales.
I am here. Good morning
Oh,
from Chicago.
welcome, Amando. Now, going back to Mohit, Professor Mohit, our topic for today, which is zero proof knowledge or zero knowledge proof. What is it? What is the concept behind it?
So zero knowledge proof is something, for example, let's say I hold some information and I want to prove that I am holding that information without actually giving that information. So in layman terms, let's say I am holding a secret key with me and I
Mm.
want to prove to you that I am holding that secret key without actually giving you the secret key. That is the concept of zero knowledge proof. So in like in very basic definition terms, whenever a prover has a certain information and the prover proves that information the that information is with him without actually giving the information, that is the definition of zero knowledge proof.
Are there any types of zero knowledge proof? Are there different types of it?
Yes.
And what's the difference between each type?
Okay, so I'll explain first zero knowledge proofs a little bit further. So let me tell you a story. Let's say, for example, we two are there, and there is a cave with two openings. For an example, so there is an opening A and there is an opening B. So now, let's say you randomly tell me to go inside from one opening and come outside of the other opening. And let's say there is a door in between which opens with a certain key. So now you want to see whether I am holding the key to the door. So then I can prove that without actually giving you the key or showing you the key. So how exactly that will happen is, so you will randomly tell me, okay, go through opening A and come out of B. So I'll go inside, and if I have the key, I'll come out of B. So
Mm.
now let's say, for example, it is a password or a secret number. So I can guess it one time, two times, or three times, right? But I cannot guess it every time. So now, for example, let's say every time I go inside, I have a probability of 1/2 of having the correct secret number, right? So it means every time the number of chances or number of occurrences increases, the probability reduces by 1/2. So it means by doing this experiment repeatedly, that we can say that the possibility of breaking this zero knowledge proof concept is very high. So you cannot kind of, you can say, break it down. Now, let me explain some properties of it. So, first property is completeness. Completeness is something, let's say, as a prover, I want to prove you something. And if I have the correct information, then I will always generate the correct proof. So, there is no way I can change the proof or I can change the information. And soundness tells that the next property is soundness. So, let's say, for example, Amando is a malicious attacker in the network. So Amando tries to create a proof based on the secret information I have. So the verifier will certainly know that in the first attempt itself. So when a malicious intruder wants to intrude without having a secret key by just guessing it, so it is not possible to generate a zero knowledge proof. Now, when you tell there are types of zero knowledge proof, So it came from this itself. So let's say, for example, if the interaction between the prover and the verifier happens again and again, so that means it is interactive. So that is our first type, interactive zero knowledge proofs. Then the second type comes in as non-interactive zero knowledge proof, where the prover gives the zero knowledge proof only once to the verifier, and verifier will have only one chance to kind of, you can say, verify whether the prover is holding that information or not. Now, why we are discussing two types, or how one is more important or one is more feasible than the other. Let's talk
Mhm.
about interactive. So, for example, let's take an example of a bank. Let's say I want to prove to a bank that I am the correct user or I am a validated user to use the funds, right, in my account. So now, if let's say, for example, I want to do 100 transactions in a day, and if it is an interactive zero knowledge proof, so I'll have to interact 100 times with the bank. So it means the bank, and both me and the bank needs to be available online every time whenever I want to do a transaction. So that is complex, and that is not efficient computationally. So that's why we kind of avoid using interactive zero knowledge proofs in real time applications. So that's why we use non interactive zero knowledge proofs. So in non interactive, the verifier and the prover need not to be online always. They can just be online whenever there is a proof generated. So these are the basic types of zero knowledge proofs.
Are there any cryptographic primitives used in zero knowledge proof? And if there's one, maybe you could talk more about it, explain the role of these primitives in ensuring the security and privacy.
Absolutely. So, cryptographic primitives mainly which are used is asymmetric key cryptography. So that is using usage of public and private keys. So when we talk about asymmetric key cryptography, so there are two keys for a particular user or for a particular participant in the network. So private key is something which is a secret to a user, and public key is something which is visible to all the users. So these two cryptographic keys are used for signing and verification. So for example, whenever let's say I want to generate a proof, and I want, like, banks wants to check whether it was generated by me only or not, right? So let's say if I sign a proof with my private key, so the bank can verify with my public key whether this proof was generated by me or not by just simply doing the signing and verification algorithm processing. So this is the cryptographic primitive which is used. So then there comes the hash function which is required. So hash function, what exactly happens is it is a one way function where you gives any kind of input and you will get a fixed length output. So that is the second cryptographic primitive which is used in zero knowledge proofs. There is one more, that is symmetric key cryptography. So in multi-party computation algorithms used across ZK snarks, so there, we can use you can say symmetric key cryptography, where a key is used
Mhm.
across the validators to generate a secret proof and validation key. So that is also one of the cryptographic primitives which is used. So yeah. So as I talked about ZK snark here,
Mhm.
so whenever we talk about non-interactive zero knowledge proofs, so there again comes a category, that is ZK snarks, ZK starks, and bullet proofs. So ZK snarks has a lot of real world value, which I am
Yes.
going to explain.
Before we go into the applicability, real world value, and the current use, limitations of ZKPs, are there any potential weakness that you see on this vulnerabilities that needs to be addressed?
Yes, there are you can say there are some which needs to be addressed. So right now there are, you can say, there will be limited number of transactions in the blockchains right now which actually zero knowledge proof is solving. But while solving this problem, the computational complexity is increasing. So that is something which is going to put a burden on the computation power, because
Mm.
computing a proof is not a, you can say, easy computational process. So it takes time as well. So when we talk about certain ZK solutions, sometimes it takes 2 hours to generate a zero knowledge proof. Yes, it addresses a problem where we are doing batch transactions, or we are you can say collecting a lot of transactions in a single batch and releasing a batch every 2 hours, right? So that is the major challenge. Then there are solutions like where centralized sequencers are used in ZK rollups. So that is the another limitation. And when we talk about, as I talked about multi-party computation, so there also the proving and the validation key can also kind of, you can say, can be compromised as well. There can
Mm.
be a hacker, or even the compute, like the nodes which are computing this validation key, they can also collude with the network. So these are some of the limitations, and also the education and awareness. So
Mm.
right now, as it is quite complex, I mean, this concept is there from 1980s, but blockchain actually made it mainstream with its applications. So it was used in kind of, you can say, research only, because the applicability was not there, the computational power was not there. So now, as we are moving towards quantum computers, so that might also become a threat at a certain point, because they might break 256-bit privacy. So that is
Mm.
asymmetric cryptography. So these are some of the limitations. But yes, I mean, if the quantum computation world is evolving, the ZKP world will also evolve, and it will become more secure with time.
What specific blockchain are we talking about that would fit on this one?
So there are a lot of solutions, like a lot of blockchains which are like, you can say, coming into picture. I'll name some. So ZK Sync is one of the prominent name, and Polygon ZK EVM is the another one. Then we see a lot of other use cases, or a lot of blockchains like Scroll, Linea, and a lot of other examples are there. Taiko is there. So these are ZK rollup solutions. ZK rollups means these are layer 2 blockchains which actually kind of, you can say, collect transactions or batch transactions and then send it to L1. Now,
Mm.
why there was a requirement of this? As we know already that making a transaction on Ethereum is quite expensive, because I mean, like, the computation power is quite high.
Mhm.
So that's why, like, it takes a lot of gas to kind of, you can say, compute a single transaction. But now let's think about it. Let's say this single transaction can be a, you can say, can be a batch of multiple transactions. So this cost can be divided into multiple users. So that's why L2 solutions like ZK Sync, Polygon ZK, VM, Linea, Scroll, all these solutions came into picture. What they do is they actually club a lot of transactions. They actually batch multiple transactions in a single batch, and
Mm.
then they kind of, you can say, send it through a sequencer to the L1 chain. So it actually reduces the cost or the burden of transaction cost from the users, because every time the users were paying a lot of gas fees when they were making individual transactions on L1 chains like Ethereum. But now, as they are doing transactions on L2, so there the as the batch is having a lot of transactions inside, right? So it reduces by that factor. So that is where, like, these blockchains come into picture, and it is helping the blockchain community in like bettering the user experience in terms of reducing the gas cost and making transaction faster, so that we can make scalable applications in future.
Amando, do you have any questions for our guest, Professor Mohit?
So far, none, but I'll follow up later.
Going to, should I say, the value of it, looking at the applicability and current use, you did already discuss some of those, and maybe you could expound more the key benefits of using ZKPs in blockchain technology and how they could address the scalability and the privacy.
Yeah, absolutely. So as I told about scalable solutions or scalability solutions where zero knowledge is used. So let me just explain it how it is done.
Mm.
So let me just go into the detail. So what exactly happens is, on a L2 chain, or you can say on a layer 2 blockchain, a lot of transactions get clubbed into a single batch, and then a zero knowledge proofs gets generated there at a sequencer node. So sequencer node is the node from where the communication between L2 to L1 exactly happens. So this sequencer node sends this batch with the metadata, or you can say with the proof of all the transactions happening on L2. So what exactly will happen? A lot of transaction will happen, a batch will be generated, a zero knowledge proof will be generated out of that, and that proof actually gets submitted by the sequencer to the verifier contract, which is deployed on L1. So now L1 chain has the proof that these number of transactions or these transactions has happened on L2. So it will simply verify the existence of those transactions without actually doing the computation. as we have separated out the computation from L1 chain, it is going to reduce the computation cost for the users. So that is where these scalability solutions comes in.
Mm.
Now let's talk about other spectrums. Let's talk about privacy. Now there are a lot of solutions like Zcash. Zcash is somewhere where private transactions are possible. So now when we talk about blockchains, we always say that it is transparent, but in a business use case, everything transparent is a problem as well, right?
Mm.
So solve that kind of issue. Let's say I'm doing banking transactions and I don't want to show my data to anybody. Simple, like in a simple way, right? So let's say I want to do private transactions. So Zcash is the prominent example where private transactions are possible. Now lot of other solutions are coming up as well, which actually provides privacy at a smart contract level as well, which means they will provide access control on your data at a smart contract level, to whom and how much data you want to show. So it means the existence of data is there, but it will be visible to only those who are actually valid, or you can say allowed to use that data
Mm.
or see that data. So that is where privacy solutions are getting developed. So Aztec is one of the examples, Elio is one of the examples. Then like Zcash, Tornado Cash are the other examples of private transactions. Then comes in like in the privacy space, when we talk about identity management as well. So we hear about decentralized identifiers, which are like simply private keys and public keys. If let's say we club this particular concept with verifiable credentials, for example. So now let's say I have a certificate, and based on my decentralized identifier, I generate a verifiable credentials. And if- it means I don't generate it. It means the issuer, like let's say, for example, I graduated from a university. That is the document I am kind of, you can say, I want to validate with some like you can say employer. So the institute can simply generate a verifiable credential for me. The institute becomes the issuer,
Mm.
and then I am the prover that I am the owner of that particular information, and any employer can verify whether I was graduated from that university or not. Now there can be a lot of use cases around it. Let's say I don't want to show my passport to all the hotels. I don't want to show my like banking details for a credit card. Like I don't want to show my salary to any bank, right? Like to get a credit card, I just want to show, okay, I lie in this range and this is my credit score. That
Mm.
is what you need, right? So these kind of applications are there in privacy space. So in terms of interoperability as well, like there is one more domain where ZK is helping. So that is where cross chain bridging solutions are coming up. So it is somewhere like you can say multiple blockchains will kind of, you can say, club with each other or interact with each other using zero knowledge proof ecosystem. So that is also somewhere like you can say the cross chain communication, cross chain consensus based like you can say network relay networks will also come into picture and will solve the problem. Because today, yes, cross chain communication is existing, but if it is existing, then sometimes it is quite centralized, which is hackable. We have heard
Mhm.
hacks like Ronin Bridge hack and other hacks. Like we have heard a lot of hacks. So then, if decentralized solutions exist, then there the problem is that they are transparent. Let's say we want to make it private as well. So cross chain private transaction. Let's think about, there are a lot of blockchain, but there are private cross chain transactions possible.
Right.
So Ironfish is one of the solution which is working on that side. So I mean, like ZKP is going to solve all these scalability, interoperability, and privacy issues, and they will have real time and real life impact on almost all the users who are going to use it.
Do you have an existing example of a project that you're doing?
We actually have implemented DIDs, or you can say the ZKP identities in
Mm.
our like some of our projects. So one was on real world assets. So let's say, for example, I want to list an asset, right? So there needs to be a verification process where it actually verifies the like the owner of the asset first thing, then it actually also verifies the existence of that asset. So now that also needs to be verified in a zero knowledge way. Why? Because why a platform will get access to the property data of particular asset owner, right? Or an asset as well, right? So there we implemented zero knowledge proof for real world asset tokenization, where we were tokenizing gold and properties and vehicles and like you can say machineries as well. The use case was to let's say if you own a particular property and if you want to secure a loan against it, so you can simply list your property. At the first, a verification will happen at a user level, where this is a zero knowledge based, you like you can say user verification, where it will verify certain details based on the ID provided or based on the verifiable credential which gets generated for you. Now the second level of verification happens at asset level, where asset gets verified based on the oracle data or based on the government data which we get. So we integrated our solution with some of the government APIs, where it actually shows who is the owner of a particular asset. Now if it gets verified in a zero knowledge way, then the two-step verification has happened, and now the user is able to secure loans, and the investor also can simply invest or give peer-to-peer loans based on real world asset tokenization. There are other examples as well. We have tried implementing and we have implemented as well. So data access control using ZKP, where I can show like only the I can show my data to only to the allowed people. So
Mhm.
we had a healthcare use case. So now the problem today is that we see multiple doctors, right? Like the allocation keeps changing, and I mean, a lot of things happening, right? So there is no centralized record of any data, right? So if, let's say for example, if there is a centralized record and I want to show that data only to the doctors, not to everybody, so I can simply implement zero knowledge proof there, and there is a allowance mechanism which I'll put in my application, and that will simply ask user every time when the doctor wants to see the record. But it is a centralized record of all the healthcare history I
Mhm.
have, and then that can be verified in a zero knowledge way as well. So that is the kind of applications which will come up. There is a lot of real world impact in the banking sector, healthcare sector, and in the blockchain sector also. So it is going to change how we see blockchain today in the next coming 4 to 5 years.
Yes, because the way I see it, it's like because we talk about blockchain, we talk about trustless technology. So with this one, it's trustless technology on steroids. That's how I see it.
Yeah,
Now,
we can call it.
in the future, how do you expect ZKP to evolve? And the other thing is, before going to the future, but the adoption of the blockchain community, where are they on this?
So right now, if you ask me that everybody in the blockchain space, even like I'm just talking about blockchain space, everybody understands ZKP, then I would be wrong to say that, because it's a cryptographic concept where, like you can say, you need a technical understanding of that,
Mhm.
and there are tools and frameworks which are not available right now at developers disposal also. So like let's not even talk about users right now. Even for developers there are not relevant tools at this point. So that is the gap which needs to be filled first, where developers, like we get proper tools and frameworks for the developers to kind of can say generate these proof easily and also faster, because as I told, like it takes around like 2 hours to generate a proof. So if we can reduce this time, that is first thing. And the second thing is, like if we can develop such tools and frameworks for developers, so that developers can make life easier for users simply. So a better user experience based real time applications will only come when these gaps are filled. So that is where future kind of you can say is going to behold these things, where a lot of solutions, a lot of tools and frameworks will come into picture. Right
Mhm.
now almost like majority of the blockchain community is heavily dependent on solidity, right? And like every day if you will ask developers also to learn a new language, it is not possible. So right now like generating proofs with solidity is either expensive or is either not possible. So these are two limitations which we have. So if that, like you can say, that is solved, then it will be sold at a user level as well by the developer community. So that is the one gap which needs to be fulfilled. And the second gap which is there is the education, so and awareness as well. So when we like you can say, if I tell someone who understands ZKP that this is the benefit ZKP has, so they will be using it, right? But if I'll be telling to a normal user, then it becomes difficult to explain the technology. So education and awareness is very much required to explain this concept, and this is where the gap needs to be filled as well. Proper education and awareness framework should be developed and should be distributed to the community, should be provided to the community, and that will also happen in next 1 to 2 years. So once these two gaps are filled, then we talk about better user experience and proper usage of ZKP, where we can say educate this concept in a very layman terms. Let's say you like own information, you don't have to share the information. The system will not take your information simply and will not store your information. That is very important. So people are realizing the importance of keeping their identity as a secret because of hacks happening. So that will actually change the mindset. And these are the gaps which will be filled in next, we can say, 4 to 5 years, where we will see ZKP as a, like, say, bread and butter of blockchain and other Web2 applications as well.
We
Okay.
have a question here from Amando. Go ahead, Amando, please.
Yes. Thank you, Dr. Vince. So, Professor Mohit, I have a question. So, this is advanced feature in cryptography, ZKPs or zero knowledge proof, and our fellow blockchain professionals are listening on this show because this is part of the continuing blockchain education. So the question is, how would ZKPs integrate in artificial intelligence, or will it integrate? Will it merge? Uh, because people argue that features in blockchain will be the bedrock of the fourth industrial revolution, specifically in Web3, to make sure that the transaction online is secured. So people may use other technology to secure their transaction, and other people argue, especially in the blockchain industry, they use this, zero knowledge proof and other cryptographic features to secure online transaction. Will it integrate to artificial intelligence, especially in Web3 space?
Okay, thank you for asking this question, Amando. As the trend is towards artificial intelligence, we also understand that artificial intelligence requires data. So when we say, like, we want to make your information private, we want to keep your information as a secret, and we don't store this information, then kind of you can say making a, like you can say, culmination of these two things a little bit tougher. But still, if there is a access to a certain data, like there are data points which needs to be secret, and there are data points which might become public at a certain point. So if, like you can say, AI models needs to be developed as well, so yes, only for the learning purpose that data can be provided to the models, making sure that the user privacy is not getting hampered. So that is where, yes, AI and ZKP can kind of, you can say, work hand in hand. But if we say we want to keep this completely secret, then it is a little bit difficult to manage with both the things, because we are saying we are going to provide the data as well, and we are saying we are going to keep this data as a secret as well. So we cannot go in both the direction, because these two are things are like little bit opposite. But still, like you can say, it can be, like you can say, designed in a modular framework where like the data, like you can say, the secrecy or the factor at which the data needs to be secret can be defined. It can be a modular structure where we can define that this is the sensitivity of this particular data information, whether it can be used in AI model or not, or whether like it cannot be. So this is how right now I see it. But yes, we will see how future is going to solve this problem. Right now, I would say they are like a little bit opposite. Yes, applications can be made, the data can be used which is not quite sensitive, but ZKP and AI, there will be a lot of research and development required to make these two technology work together.
Okay, thank you so much. Right, so two more questions. Um, there are, aside from blockchain professionals, blockchain developer listening in this show for the continuing education requirement, we also require this with our partnership in Althash University for our students who are taking blockchain studies. So to give them inspiration, we would like to ask you, how did you start in the blockchain space and what made you attracted in this industry? And then the second follow-up question is blockchain formal training such as certification or accreditation important in 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 your or people's professional development? Any thoughts about that?
Absolutely. So when I talk about myself, how I started, there like one blockchain kind of, you can say, introduction lecture happened when I was in my university. So something similar to this, which we are doing right now. So I kind of, you can say, understood that this is going to become the future because everybody was talking about decentralization at that point, even for web 2 applications, Kubernetes and all these solutions were coming up. So decentralized computation was becoming a norm. Then I found the interest in the immutable concept where the data cannot be changed. We have seen a lot of use cases where people kind of, you can say, were like cheated by changing the data, or their data got hacked or something of that sort. So I found that interest. And the main thing which I understood about blockchain is that like it is not one technology which kind of, can say, we cannot say blockchain is one tech. We can say blockchain is a combination of multiple technologies. It is a combination of peer-to-peer networking, cryptography, then networking, then a lot of other things, consensus algorithms, and a lot of other primitives which gets integrated. So blockchain is simply nothing new. It is a combination of very traditional technologies which existed in 90s also. So right now, the interest which I got developed is because of the cryptography, because I knew that it is like, you can say, going to change the future in terms of privacy as well. And again, alongside the decentralized concept, or having every information with you in a decentralization way, so that is something which kind of, can say, interested me in this. Then I started learning by myself. If you want to understand how I kind of, you can say, adopted everything, I did a lot of self learning. I used to kind of, you can say, read a lot. I used to see a lot of lectures. There was not a lot of kind of, you can say, resource available as well at that point. So simply just keep exploring. If you get a chance to do a certification which will give you a validation as a student or as a professional as well. So if you get a chance, do a certification as well. And simply keep your interest alive in the technology. If you are really interested, break it down into multiple like, you can say, domains or multiple technologies. Understand each of them separately, and then understand the combination as a blockchain, or how zero knowledge proof works, because zero knowledge proofs are also kind of, you can say, part of cryptography. So simply, if you understand cryptography, if you understand basic primitives under cryptography, then it will be very easy to adopt like blockchain and zero knowledge proofs as a whole. So this is how I kind of, you can say, did this. I have worked professionally for almost 6 years now. So initially I started as a student itself, like you all. And I mean, the interest in the technology kept me going. I got a lot of mentors in between who helped me a lot. And then the industrial experience and also the academic experience, I published 2 research papers in blockchain as well, which gave me the confidence that like this is going to actually change the future of internet, or you can say internet applications. So just keep yourself interested in the technology. Keep kind of, you can say, keep exploring, keep reading, keep like watching such workshops and lectures. And then if you have questions, reach out to people. You can reach me out as well. You might get contact details from Amando or from Dr. Vince. So this is how I started, and yes, certification gives you certain validation. So if you feel that you want to get such type of validation, go for certifications as well. Complete courses. Don't try not to leave things in between. Try to finish things, understand things as a whole, and once that happens, then I think it will change your career for, like, you can say, in the future. So these are my answers for these questions. Hopefully I could answer what was asked.
Thank you so much, Professor Mohit and Dr. Vince.
Final thoughts, and at the same time, you want to do a shout out or promote something where they can go to, how they could contact you, which we will put it down on our description box below, your LinkedIn account. We will share it, and I'll give the floor to you. Go ahead, Professor.
Okay. Thank you so much, first of all, for inviting me to this session. It was quite interesting. The questions were really good and on point as well. So, what I want to conclude about zero knowledge proof or blockchain as a whole, that it is going to change the world for sure. We are moving towards more private, more transparent world, more decentralized world, where we can trust the like you can say computational systems instead of third parties, or instead of banks. We will have a lot of use cases, lot of good use cases, like cross border payments and micro payments, and maybe everyday transactions will also happen through blockchain and zero knowledge proofs. There will be a lot of financial and decentralized finance applications. The transformation will happen in the identity and authentication domain as well. The evolution will come, as I talked about, verifiable credentials. So that will give more control to the users. We are moving towards user centric world, so that is already happening, and we will kind of, you can say, the ecosystem will mature, and it will give more responsibility to the users as well. And with responsibility, it will give power of the data as well, so to the users, which can be used in a positive and both negative ways as well. But it will have a lot of positive impact. That is what I bank on. Yeah, that is what I can conclude about blockchain and zero knowledge proof. And if you have any questions, if you want to discuss a particular technology or related to blockchain and zero knowledge proofs, so you can reach me out. I'll share my contact information with a team, and yes, like we can keep those online, certain information on online and public as well. So if you have any questions, reach me out on LinkedIn or maybe over email, and I'll try to answer as many questions as possible for you. And thank you so much again for having me on this session.
For those who are watching right now, don't forget to like, share, subscribe, and hit the notification bell so that every time we publish our content, you will be notified. This would be published or uploaded on 3 channels: the Block, iCore BP, Trade More, and at the same time, of your community. Again, thank you so much. God bless everyone. Merry Christmas. And I think can we have another session of this, Professor Mui?
Absolutely, yes. I'll be open to take such sessions. So it was quite interesting to connect with all of you, and maybe sharing knowledge is something which excites me. So I'll be available. We can talk about timings and schedule, and yes, I can do another session with you all. Yeah.
So have a great evening.